Good morning everyone. Today we will see about one of the antenna parameters, which is our radiation pattern. This radiation pattern tells us how far my signal is going to get transmitted, and with a higher efficiency that my signal is getting transmitted from one point to the receiving point. This is a simple or a radiation pattern that is obtained from an antenna during its transmission process. This radiation pattern can be compared with our simple cone structure. As this radiation pattern structure will have few of its major lobes and minor lobes, where the major lobe will comprise of the information that we are transmitting, and the side lobes consist of some small portion of the information that is getting transmitted, and there is a back lobe which is completely behind our major lobe, which contains no information at all. So only of these structures in our radiation pattern, we are comparing this structure with our cone shape. So this is the edible part in our cone. In a similar way, we have our major lobe also. This edible part in the cone is the structure or is the part which we are going to consume. In a similar way, this major lobe will contain all the information that is being transmitted, or most of the information that is being transmitted will be there in the major lobe only. The next comes the non-edible part, which is the skin of our cone, which is not at all needed. In a similar way, in our radiation pattern also, adjacent to the major lobe, we have many number of side lobes, or we can tell that as minor lobe also. Those minor lobes will not have much of the information, but it is not necessary that we have to consider those minor lobes in our analytical process. The next is the shank part. This shank is completely behind this edible part. In a similar way also, in this radiation pattern, we have this major lobe. There are few side lobes which lies completely opposite, that is behind our minor lobes, which is called as back lobes. This back lobes consist of no information that we are transmitting. So in any radiation pattern that we consider, we have our major lobe which has most of the information that is being transmitted, side lobes which consist small portion of the information that is being transmitted, but it is not necessary that it has to be considered for the analytical part, and the next one is the back lobes which do not have any of the information that is being transmitted. So this is the maximum point of radiation. So from the maximum point of radiation, we'll be calculating 3 dB below. So from that, we'll be considering half power beam width. What is half power beam width? It is the angular width in degrees measured on the major lobe of its radiation pattern at half of its lower points. So in a similar way, we have another point also, which is first beam null width. First null beam width, FNBW, which is the angular width that is measured between the first side.